discuss last category of texture mapping, and that is UV unwrapping. Previously, I explained that for this category to work properly, it needs the seams to be defined first. What I haven't explained in detail is that there are methods in this category that can generate the seams automatically. Because of this, I divide the methods into two subcategories, manual and automatic. Manual means that you still need to define the seams by hand. If not, then these methods will just generate an error message. In this manual subcategory, there are three methods that you can use: angle-based, conformal, and minimum stretch. So these are the manual methods. In contrast, the automatic methods can generate the seams on the fly. So these methods will work regardless of whether the model has the seams defined or not. Due to this, some might argue that these are not UV unwrapping methods, but are projection methods. Personally, I still think they are part of the unwrapping methods and not projection methods, because the algorithms are based on the angles formed by the faces, not projection from certain directions in space. But anyway, the categorization is not that important. It is more important to know and understand how to use the methods. In this subcategory, we have the Smart UV project and Light Map Pack methods. Let's discuss the automatic methods first, and then after that, the manual methods. For practice, let's create something more complex than a cube. We can select the face at the top, then press E, then 2 meters, then press Enter. Press Shift R to repeat the extrude. Next, select this face and then Shift R. Select the face at this side, then Shift R again. Basically, we just created a simple T-shaped 3D model. To clear the existing UV map, we can just delete the channel and then recreate it again. Okay, next, we will also need a more organic-like model. For this, let's create a monkey head model. Move this to the side so we can see it, and let's apply the same grid texture material. Finally, we can delete the UV map channel and recreate it again so we have a fresh start. Alright? The first method in your automatic subcategory is the Smart UV project. Essentially, this method will split the faces based on the angle threshold. Faces that form an angle larger than the threshold value will be split, while faces that form an angle smaller than the threshold value will be joined together as a UV island. Now, you might be wondering, what is a UV island? Basically, it is an independent structure of mesh elements inside a UV map. If that is still confusing, don't worry, I will show you in a moment. For now, let's hide the T-shaped model so it doesn't get in the way. Then select the monkey head model. Select all the faces, then open the UV menu, and then use the command Smart UV project. Here, you can define the angle limit. For now, let's just leave the value to the default, and here is the result. These groups of elements are what we call UV islands. I think we can see them better if we close the image. We can do that by pressing the X button on top. Don't worry, we can always load the image again later. Now, if we revise the angle, for example, we can make it smaller like 10. The UV islands are now smaller than before, thus making their number increase. If we set the angle to 90 degrees, which is the maximum value allowed in this case, we can see larger sizes of UV islands, but fewer in number. So, this is how the Smart UV project works. The next method is the Light Map Pack method. As the name implies, this method is suitable for creating light maps. So what is a light map? Simply put, it is a special texture for storing lighting information. Light maps are generally used in video games and animations to improve performance or rendering time. Essentially, instead of using real-light objects and having the computer perform ray tracing calculations per frame, the lighting information is baked into textures. This way, although the scene looks similar to before, the computer does not need to perform lighting calculations per frame again. The downside of this method is that it cannot be used for moving objects. So, this is mostly useful for static environments or backgrounds where the lights do not change over time. Another downside is that, unlike regular textures that can be repeated or tiled, light maps cannot be overlapped. Each of the faces needs to have a unique area in the UV map. That is why, most of the time, a light map needs a special UV map channel so it does not disrupt the main texture UV map channel. We are not going to discuss how to bake light maps in this course, but we can try using the light map UV method just to see what the result looks like. As you can see, this method creates non-overlapping faces and also makes use of the texture space very optimally. Again, usually you want to do this in a special UV map channel, and then after that, use the UV map as the basis to bake the lighting information into an image. Alright, because the overall video duration becomes too long, we will discuss the manual subcategory in the next video.